In this presentation, we will discuss airfoils. An airfoil is any surface that provides aerodynamic force through interaction with moving air. If we remember from a previous presentation, the aerodynamic forces we will consider are lift and drag. This can be demonstrated simply by putting your hand outside the window while the car is moving. Try turning your hand flat, angling your hand, and turning it perpendicular to the air, and notice the difference in forces you experience. This exercise primarily demonstrates the effect of deflection on a wing. It's important to note the airfoil shape refers to the two-dimensional cross-section of the three-dimensional wing. Just as with aircraft, we need to know the terminology for the components of the airfoil to discuss it clearly. The leading edge is the front of the airfoil at the point where it first makes contact with moving air. The trailing edge is the last place where the airflow makes contact with the upper and lower surfaces. Remember, one component of lift is the pressure differential between the upper and lower surface, so this point will be important in considering lift and drag. Chord line is the straight line between the leading and trailing edge. Note, the chord line may not be on the actual airfoil depending on the shape of the airfoil. The camber is the curve of the surface. We will discuss the upper camber and the lower camber. The mean camber line is positioned at equal distance from the upper and lower camber at each location on the airfoil. So if the airfoil is not symmetrical, the chord line and mean camber line will be different. The upper camber relates to the curvature of the upper surface, while the lower camber refers to the curvature of the lower surface. Air separates at the leading edge and travels above and below the wing. The separated air meets at the trailing edge. The upper camber is more pronounced than the lower camber, therefore the distance from the leading edge to the trailing edge is a farther distance above the wing compared to below the wing. Since the air meets at the same time, the air travels faster above the wing than below the wing. According to Bernoulli's law, the increased velocity means a decrease in pressure. A lower pressure above the wing compared to below the wing sucks the wing upward, creating lift. The top wing surface is critical for generating lift. Anything that slows airspeed above the wing will decrease lift. Major sources of velocity reduction are dirt, ice, and surface deformities. Flaps are used to increase lift and drag. Many styles of flaps exist. Flaps allow for slower takeoff and landing speed, improving safety and aircraft control. Flaps change the shape of the wing throughout the flight. Changing the shape of the wing changes the camber and chord line. The angle of attack is between the direction of relative wind, which is not necessarily horizontal, and the chord line. Remember, the angle of attack has a large impact on the amount of lift and drag achieved. A higher angle of attack increases lift up to a certain critical point. The critical angle of attack is determined for each aircraft model and is the same for that model regardless of the aircraft airspeed, altitude, or weight. The critical angle of attack is the maximum angle at which the airfoil can be positioned prior to airflow separating from the upper surface. When airflow separates from the upper surface, the flow becomes turbulent rather than smooth and laminar. Turbulent flow is unpredictable and can cause stall. Stall is a dangerous condition where nearly all lift is lost, resulting in rapid loss of altitude. An aircraft typically has a high angle of attack during takeoff and landing, so there is danger of impacting the ground before aircraft control is regained. A review of all the major components of the airfoil. If you'd like to find more information.